Connecting. Hey, hello everyone. Let's just take place here. And I hope you are all enjoying this conference, the presentations. And let's just wait a few seconds so you can join here. Let's see. Okay, so well, let's get started. Today, I want to talk about evolutionary architecture. Let me share the screen here first. And so you can tell me if you're seeing it. Can you see my screen? Perfect. It seems that people are seeing it. Okay, so let's get started. Let's get started with low-hanging evolutionary architecture. It's a brief introduction about evolutionary architectures and some practice and principles that you can start following. So it will help you to deal with changes while delivering our software. And if you have been developing software for a while, probably you have noticed that adding changes during your development process, any kind of change, requirement changes, scope changes, and technological changes, especially those that modify your core architectural aspects, can become very difficult sometimes. And you may find it difficult because they're simply very hard to implement. They impact many places and have a lot of dependencies on that place that you're changing. Or maybe it takes too long to implement because it's not just to implement, it takes too long to validate also because there are many other places that you have to look after you implement. You have to look if it impacted any other places, and they are all still working as you expected after those changes. Also, you may think it's cost too much to add the changes, not just because of the process of all this implementation to put the change working, but in the other hand, you can think about planning to predict those changes and prevent them to happen. But it also still costs a lot, and sometimes it's very difficult to predict changes during the development process. So, and there are some bad news. Those changes are becoming much more frequent nowadays. Now that we are in a more dynamic world, in a dynamic context, that everything changes in a more fast pace, and also the business models itself are shortening. We can think some business models that was working in a few years ago that doesn't exist anymore today. And if we don't change, we don't adapt to this change, we don't add the change in our software, we start to lose competitiveness and opportunities. And if you're the owner of the business, it probably be the biggest nightmare that you want to experience, because it simply can shut down your business if you lose in competitiveness and new opportunities. And naturally, all these changes happens, and they are all inevitable. I hope I'm not spoiling anyone here, but they are inevitable, like Thanos in Avengers movie, and just like Thanos exterminated half of the universe with a snap of his fingers, these changes will probably exterminate half of the softwares in the same fast pace. So it's a bad news. It's a bad thing. we have to do something with it. We have to create something that we can adapt for them. So what we can do with it in this scenario? What if we can make those changes easier to implement, reduce changes implementation and validation time, and maybe lower the cost of implementing those changes so much that we, instead of going against implement those changes, we can start to embrace them. So that is where evolutionary architecture comes into play and can help us. So what is evolutionary architecture? If you go look after references, you certainly will find this book, Building Evolutionary Architecture. That's written by the smart architects from the ThoughtWorks company, Neil Ford, Rebecca Parsons, Patrick Kwa. Those guys also are the authors of the book and coined the term evolutionary architecture. And for them, evolutionary architecture is an architecture that supports guided and incremental changes across multiple dimensions. And what they mean with it? Oops. By guided and incremental changes, they are looking at this long interval implementation changes and then applying it to our software. And then we have this, instead of having this big bang event that will apply all the changes at once in our software, they are looking after, I have to change here. They're more concerned of creating incremental change. So breaking those changes into smaller deliverables, so you can do it incrementally during the development process. You don't have to do all of it at once, and you do it in a more continuous pace. So you have more. You try to implement those changes in a short interval. This is all about relying on continuous delivery practices like deployment pipelines, automated deployment pipelines, mature DevOps, good testing cultures, to build an entire infrastructure and tools to enable you to make those changes happen more often. Since it happens more often, you will leverage creating those infrastructures and tools for your development environment. And so, and there's more. It's not just doing it incrementally and in small deliverables changes, but also in a guided way. What I mean with guided way is to measure if your changes affected somehow in a good way or in a bad way your product, your system. So how do I measure it? There is when enters the notion of multiple dimensions. You will measure every change that you have considering the dimensions or the architectural requirements, qualities that you think it's important for your software. So, for example, if for your system performance is something that is important, you have to measure all those changes. Every change that you add to your system, you have to measure it and see if it affected the performance of some place that is very important, very critical for your software, or any other aspects like scalability of your software or resilience of your software. And so you have to look at all the dimensions that is important for you, and then measure every changes for every change how it affected if you're evolving or not. And for example, if you for an example, a good example, like if performance is important and also security is important, and you add some caching in your software, but this caching somehow adds some security problems. So you have to assess those things and tell if it's evolved or not in both ways, not just on performance, but you have to keep security also at the same level of quality. So what I can do by developing to evolve our architecture? Here I will enter. This is a brief introduction. Here I will enter with some practice principles that may help you achieve those aspects of evolvability into your architecture. So the first one I want to introduce you is applying Postle's law, or the Robustness Principle. The Postle's law says that be conservative in what you send and be liberal in what you accept. So John Postle is a computer scientist that is very renowned and contributed a lot on network protocol definitions such as TCP and SMTP. And what he wants to say with it, if I take a web API as an example, be conservative in what you send is about when you're sending output from your API, from your web API. You try to be more restrictive with about what you're sending in your API. So you don't send a bunch of data that you don't know if it's even necessary or not for that API. You restrict it with just the necessary part of this data. Why? Because if you send any data to the outside of your API, of a web API, you're creating responsibility about those data. And if some client uses it, you end up having to maintain that. And if you want to take it out because it doesn't make sense at some point of your of the development process, so you have to validate for every client if someone is using it and if it breaks anything that's more important. So you try to follow, try to restrict as much as you can your output. And by being liberal in what you accept, is the opposite side. When you receive input in your web API, you try to be more, as the name, robust, or more resilient to the format of this input. If there are some optional data that you can handle it by defaulting some value, or there are some format that you can interpret it and then treat it somehow differently, and that don't break your system, your API in the end, then do it. So you add more flexibility to your API to accept more to accept inputs in the many formats, and also when something changes in the client side, it doesn't affect or it doesn't break your API, your web API that is receiving the input. Okay, so following this principle will help you end up with more resilient components that are more flexible for changes. So so you can change some small changes that won't break your system in the end. So that's some way to help you achieve evolvability. Another principle that I like here is to follow is the less responsible moment principle. Less responsible moment principle is about postponing decision as much as you can. So why I will do it? In this chart, you can see that the cost of this making a decision and the cost of deferring it or postponing it. And the less responsible moment is when both the costs cross each other. So what is the cost of making decision earlier? It's all about the risk that you have to decide it earlier or prematurely, and then something in the context or something in your project changes, and you just have to redo this change or undo what you did and redo all the things that you have to do. So as much as you postpone, you have lower risk of changes to happen, and then you have lower cost of deciding. So as the more you know, the less the less risk you have to decide something in your software. And in the other hand, if you postpone, there are some things that that will be that will be dependent on that decision. So as much as you postpone, those decisions have to those other decisions or actions will be postponed also. So there's a cost of postponing everything else coming after this decision. So you have some cost here that will raise as much as you postpone. So the less responsible moment is when those two crosses each other. And when Venkat said about less responsible moment principle, he told here some 3 rules to follow, easy to follow, to help us. That is the cost of deciding. If the cost of deciding now is higher than the cost of deciding later, then you just postpone. There's nothing to think about because the cost is higher deciding now. Is better to decide later. And when the cost of deciding now is exact same, or is the same of the cost of deciding later, and also postpone. Because if it's the same later, you have more context to decide better, to have better decisions. And but when the cost of deciding now is lower than the cost of deciding later, in this case, he says to evaluate how much higher, because even if the cost that you decided to put here to compare the decision now and later says that is lower to deciding now, you may have some some advantages to wait a little bit and to afford this difference, to have better context, to have better information about the context, and then have better decisions. So here we must evaluate how much higher. If it's very much more higher, then you have to decide. But if you can postpone a little bit more, maybe it's some advantage for. And then we have fitness functions. That is maybe one of the most important features when you are trying to implement evolutionary architecture. They are functions that will evaluate your system. Instead of evaluating your requirement, it will evaluate your architectural requirement or qualities, or that multiple dimensions that I said before. So you create any tools, anything that can automate or automatically evaluate it, like creating quality tests that will, like if I say the performance metric, so I will create tests to evaluate the performance of the software every changes that I add to our software. Or maybe if test is not possible to create, maybe system monitoring to it, or any other process metrics. Anything here that will help you track those dimensions, those architectural requirements, are some kind of fitness functions that will help you to evaluate if any change that you make are having a good impact into your software. And the last, and not least, Simian Army. I don't know if you heard about it before, but are tools created by Netflix to simulate chaotic environments. So, like Chaos Monkey are a tool that randomly shut down virtual machine instances and containers. So it will see if, as randomly shut down, you see if your system are resilient enough to respond to those things. And also Gentle Monkey that will remove unused files, automatically remove them. Latency Monkey that will add latency and inactivate services also randomly, so you can see if your system will keep working even in those environments. This is some kind of fitness functions that will help you evaluate if your systems are the resilient part of your system. If your system passes some tools that will simulate chaotic environment, so you can be more confident that it will be more it is resilient to enough to push it into production. And as an example, like and you don't have to use Simian Army from the Netflix. You can implement your own. You can implement like in a project that I worked. We implemented that WebDriver bots that will enter our system, access the browser, and enter our system, and they start to create and edit and delete a lot of things. And we can see if the system still working good. So we can say that our system are good enough for 10 or 20 anxious users that are clicking all the screens in our system in the system. So that's some examples that you can implement here. And yeah, and that is all that I want to share with you guys today. It was it's very brief, and the question is: are you ready to evolve? If you need to evolve, of course, are you ready to evolve your system and keep them evolvable as much as you can, as you need? And well, that's all. If you have any question, you can ask on the chat. And if you want to see more of software architecture, please you can go to the link and download my ebook. There are other architectures that you can take a look. Thank you.